All right, so let's introduce the salivary glands. So you have a couple of different types of salivary glands. You have these intrinsic salivary glands, and these are going to be unicellular glands that are very similar. If you remember glands way back in 2401, one type of unicellular gland we talked about was mucus glands. So these intrinsic salivary glands are going to be unicellular glands. They are associated with buccal glands, or buccal glands, lingual glands, and labial glands. And what they do is they are, of course, since they're glands, they are going to secrete substances and they are going to contribute to saliva. You also have extrinsic salivary glands. This is where most of the saliva is going to be produced. So these are going to be the main ones: your parotid, your submandibular, and also your sublingual glands. And these are all named for where, or specifically like the submandibular and the sublingual are going to specifically be named for where they're going to sit in the mouth. All right, so these are going to be your salivary glands here. The parotid is going to be the largest right here. That's salivary gland. As you can see, there is the duct. So the saliva, the different components of the saliva, and it doesn't produce every single component of the saliva. We'll talk about how the components of the parotid gland here in a minute. But there's the duct, and it is going to empty, as you can see on the roof of that mouth. It actually only produces 20 to 30% of saliva. So it's the largest, but it does not secrete the most. The one that does is going to be the submandibular gland, and it's known as submandibular, appropriately named there, because you can see there's the mandible right here, and it is going to be located underneath it. So, but the submandibular is going to be the one that produces the most of the saliva. And then you have the sublingual right here. Sublingual is going to be the one right underneath the tongue. So you can see the ducts that are going to go with the sublingual. And if you notice, there are little holes right beside your lingual frenulum. And I'll go back to this picture of that lingual frenulum that I was looking at. You see those teeny tiny little holes. There's the little hole right here. There's bigger holes right here. And what these are going to be where the saliva dumps in right underneath the tongue. You might have even experienced this. If you're super hungry and you smell one of the, your most favorite foods, sometimes you can just feel the saliva coming out of those glands and underneath your tongue whenever you're really, really hungry, because that's a lot of times that's when salivary glands secrete their the substance is going to be when you're hungry. So saliva is going to be produced by two different types of cells: mucus cells and serous cells. What mucus cells secrete is something called mucin. And mucin is really just going to be mucus whenever it is combined with water. These serous cells are going to secrete a watery substance, but what it contains is our very first enzyme that we are going to introduce here, called salivary amylase. So all of these enzymes are going to be named by what they break down. Remember, that's really how our enzymes are named. There's the ASE, which is telling us it's an enzyme, and so it is going to tell you that it is going to break down specific types of starches. And we'll talk about the different glands. There's a nice little chart that's going to tell you that we'll cover and tell you the different glands that we went through that are going to secrete more mucus. One's going to secrete more of the enzyme-rich fluid, and one's going to secrete a mixture of both. But this is just kind of showing the histology of a salivary gland. It's really, really nice. So there is the serous cells right here, but then this one is going to have mucus cells, so this is one that is going to secrete both of them. So let's take a look at saliva, how much we secrete, what it's composed of. So we actually secrete 1 liter to 1.5 liters of saliva a day. Can you believe that? That is a lot of saliva if you think about how big a liter. If you go and get one of those liters of water, it's a lot, and that's how much saliva we're producing. Most of it is going to be during mealtime. If you think about it, yeah, that's the smartest time to produce saliva, because it's going to have an enzyme that breaks down some food substances. 99.5% of saliva is going to be water, and it's going to be a mixture of different solutes. So we're going to have salivary amylase in here. Again, that's that enzyme that helps break down starches. It's going to also have that mucin in there that is going to, of course, upon hydration, it's going to turn into mucus. Also, lysozyme. This is going to be another kind of substance that is going to be very similar to an antibacterial. It goes in and helps break down any kind of microbes that we might ingest with our food. Some of the main functions of saliva is, of course, it moistens that food with that we are ingesting. If you think about how hard it would be to go in and chew food when you don't have a lot of saliva, like bread or anything like that, it would be really hard to break down food. Since we do have enzymes in here, this is where we are going to start chemical digestion here. Also, saliva is important to make sure that we taste things. So remember that with olfactory receptors, the food molecules, if you want to taste it, it has to be dissolved in a substance, in a liquid substance, and that's going to be saliva. So once it's dissolved, it can go in and bind to those little taste receptors, and that is going to be another importance of saliva. If you don't believe that it's important to taste food, then go in and take an onion or something that has a really strong taste and eat it normally, just a little piece. I'm not telling you like eat it like an apple or anything like that, but just a small piece, and then go in and dry your mouth out, blot it out with a paper towel or something like that, all of the saliva, and then chew another piece of onion and see how the difference is, how it's a little bit less strong than normal. So again, I talked about that antibacterial substance, that lysozyme that is going to be found in it. You also have some antibodies. You have your IgAs in here. And remember, IgAs are found in all of those different secretions of the body. So as far as regulation, it's going to come from the autonomic nervous system. And specifically, what stimulates it is going to be parasympathetic. So remember, with the autonomic nervous system, that parasympathetic is known as rest and digest. So anytime that we need to digest food, it's going to come from parasympathetic stimulation. Anytime that we don't, then we are going to, that's going to back away. So it's regulated by salivary nuclei that is going to be located in the brainstem. So we have that just basic level of salivation in response to parasympathetic stimulation. So what happens is we take in food, and these receptors, these chemoreceptors, are going to detect the food in our oral cavity, and then it sends that signal to the salivary nuclei. Actually, before you even put food in your mouth, you are secreting saliva, right? So we'll talk about how even just thinking about food or seeing food can stimulate it as well. So that's what it's talking about here. You can receive signals from higher brain centers in response to just thoughts of food or smells or anything like that. So increased parasympathetic output to salivary glands is going to go in and help increase salivary production. There's other things that can go in and stimulate our salivary glands, like vomiting. Anytime that our body knows that we're about to vomit, if you've ever noticed what happens right before you vomit, your mouth just fills with saliva. And what it's doing is it's going in and protecting your mouth for what you're about to vomit up. And because really it's going to be a lot of stomach contents, which is very acidic. So you need to go in and protect your teeth. And saliva is a really good way. I mean, it's not going to completely protect it, but it's better than nothing. But it's also going to help ease that vomit out as well. So with lubrication. So that is another thing that's going to kind of go in and stimulate salivary secretions, is going to be that vomiting center. So if we take a look at the parotid gland and what it secretes, the parotid is strictly serosecretions. So the parotid is mainly going to be that watery fluid that is going to be rich in salivary amylase. The submandibular is going to be a mixture of both. and so is the sublingual. So the submandibular and sublingual are going to secrete more serous and more of the mucus secretions here as well. So if we take a look at another thing about saliva characteristics, what's found in here, of course, we're going to have ions, but we're also going to have something called lingual lipase. So this tells you where it's secreted from. Not from the tongue, but it's going to be around some from these salivary glands around the tongue. But it is going to break down fats, but it's actually not a really strong fat breaker downer, if that's a really good word. I guess I should say digester instead. So it's not the best at breaking down fats, but it's there. We'll talk about how we have a better enzyme that breaks down fats, and that's going to be a little bit later on that we'll talk about that. So pH is actually slightly acidic. It is going to be between 6.4 and 6.8. So let's take a look at how we begin our mechanical digestion here. So chewing is going to be called mastication. And what this does is it goes in and helps us break down food and reduce it to a size that we can actually swallow. Another thing that it does is it helps increase the surface area of food so that all that salivary amylase that we just secreted is going to be able to be exposed to the food, and we can help break down as much starch as possible. Chewing also is going to promote salivation. If you think about it, how you chew, one thing, even if you just chew on paper or chew on a piece of plastic, it promotes salivation. You're going to salivate a lot more. Mastication is going to require a lot of different structures in the mouth: the teeth, the tongue, the lips, the cheeks, and the jaw. So we actually have a mastication center. We have a chewing center. Remember, most of our reflex behaviors are going to come from the medulla, and that's exactly what we have here. The medulla and the pons are going to be where the mastication center is going to be. So that's how this is going to be controlled.